Right, I'm looking at question 5. I'll tell you why. Because it's got this here, it's quite nasty. So I've got this equation, y equals 2x squared, take away 7x's, yuck, then add 5. Right, this is as grade C as it can possibly get. And they've given me a table to start off with. I don't like it, I hate the way they do it. And I'm going from 0 to 3, but going up in halves. So it's what I've got, 0, 0.5, 1, 1.5, 2, 2.5, and finally 3. So, you know, really tricky. And I may use a calculator for this because, well, it's a little bit long in it. Look at it. My coordinate's going to go there. Extend the line. So here I go. Y equals 2 lots of x squared. Take away 7x's, then add on 5, and then get your answer. And I will get some coordinates with a bit of luck. So here I go. Well, if I put 0 in there and 0 in there, nothing plus 5 is 5. So I've got the point 0, 5 straight away. Now I've got to put 0.5s in here. So here I go. 2 lots of 0.5, or rather 0.5 squared, then times it by 2. Then take away 7 lots of 0.5, and then add 5. Let's see what I get. Let's use my machine. I will use it this time. So 0.5 squared equals that. 0.5 squared is that. Now times that by 2 is 0.5. Yeah. Now what is 7 times 0.5? Well, it's going to be 3.5, so it's minus 3.5. Then I'm going to add 5. Well, I made that 2 on my calculator. Again, I don't really trust calculators with these things, but I've got to do it. So I've got the coordinate 0.5, comma 2. Right, so let's put 1s in there. 2 times 1, after it's been squared, take away 7 lots of 1, then add 5. I made that 2, didn't I? Right, so what I've got here, that's going to be 2, take away 7, minus 5 plus 5 is 0. So I've got the point 1, 0. Next one, 2 lots of 1.5. After it's been squared, take away 7 lots of 1.5, and then you add your 5 afterwards to get an answer. So 1.5 times 1.5 times 2, that's me doubling it. Take away 7 lots of 1.5, close my bracket, and then add 5. This gives me an answer of minus 1. Well, let's hope the calculator is behaving. So it's going to be 1.5 along the x and minus 1 down on the y. This one, 2 lots of 2 squared, after it's been squared up rather, minus 7 lots of 2, add 5. Right, that's going to give me 4, double up 8. 8 take away 14 is going to be minus 6. Minus 6 plus 5, minus 1 again. Strange, isn't it? So 2, minus 1. If I've made a mistake, then what's going to happen is the graph simply won't look like a lovely U-shaped curve. I have to go back and self-correct. Now if this happens to you in an exam and it looks wrong, probably means it's wrong, so you can just self-correct as well. Alright, so 2.5 times 2.5 times 2, that's 12.5, and then take away 7, open bracket, 2.5, close bracket, then add my 5 on at the end. It gives me 0. Well, this is going to be horrific. Look at it. So 2.5, comma 0. I'm going to have a lot of fun doing this. Right, 2 times 3, that's been squared. Take away 7 lots of 3, then add on 5. Right, 9 times 2, 18. 18 take away 21, minus 3. Minus 3 plus 5 is 2. Can't wait to see how this looks. So I've got 3, 2. Right, I've now got to plot this little thing here. And any negative values on the x? No, it's all positive. And what about on the y? So 5, 2, 0, right, okay, got it. Let's do it nice and big. I'm going from 0 to 3 here. Start about here, I reckon. 1, 2, so, no, 0.5, 1. 1.5, 2, 2.5, 3. Let's just extend it anyway to see how far it goes. See how this is going to look. That's 0. That's going to be 0.5. Yeah, really expand the scale so you can see what's going on. 1.5, 2, 2.5 and 3. That's my x-axis sorted. My y-axis goes up to 5, but then down to -1. So let's try and do that. 1, let's just do as much as we need and then get rid of what we don't want. Can also do halves here. Oops, I didn't like that. Ugh, nasty. You, go away, untidy. Try again. So grab this 0, 0 and come down here. Oh, I've dropped it again. Can you believe it? What you're learning here is how to play around with software. This isn't maths at all. Right, come on, don't drop the pen this time. Yeah, done it. Right, go up in halves. 1, 2, let's hope it fits. 1, 2, 3, 4, 5. It won't fit. Let's just do it like this. 1, 2. Oops, wrong one. 2. Oh dear, it's all. Do it again. I'm getting so tired. 1, 2, 3, 4, 5. Let's go 6. And that's my y-axis sorted. And I'm going -1, -2 and stop. Right, get plotting straight away in red. Come on, let's do this. Complicated graph, you know, the coordinates weren't bad. So 0 to 5 is that one. And then 0.52, 0.5 along and 2 up, there. 1, 0, there. 1.5 -1, so that's there. 2 -1, that's there. 2.50, that's there. And 3, 2 is here. Yep, it looks like it's gone flat. Honestly, it hasn't gone flat. What we've got is a very beautiful little curve, and I'll show you how that works in a minute. Right, watch this. I've done one of these before. Draw in the curve. Don't be tempted to go flat now. Do what it says. You know it's going to bottom out and then go back up. So draw it like that. That's it. And it's perfectly correct. That is the graph of y equals 2x squared minus 7x plus 5. Beautiful. Now look, there's a minimum point right there. What does this say? Write down the coordinates of the minimum. No, where are we now? Yeah, write down the coordinates of the minimum point. Well, look at that. Let's just put in the line of symmetry so you can believe it. So the line of symmetry, I reckon, is right here. So I'm going to draw it in. Doesn't ask me to do that. They could have asked me to do that. So that's the line x equals, that's 1.5 and that's 2. It's right in the middle. 1.75. Therefore, I reckon the coordinate there is going to be 1.75 along and maybe minus 1.1 down, minus 1.1, but that's what I'm going to go for, because from my freehand curve that's what I see. Again, I could calculate it. If I was to put my 1.75 into this and get my y, you know, who knows, but it should work nevertheless. And I'm going to pause and see what the answer book says and then get back to you. Yeah, encouraging sign. What they've done is actually calculated the y value. I've just read it off the graph. It didn't say in the question calculate the coordinates of the minimum point. It says find the coordinates of the minimum point. Well, I read it off as 1.75 and minus 1.5. Now, it's actually really, really close. They calculate it as minus 1.125, which I'm really, really happy with, which means my graph is quite accurately drawn. Now let me just do a quick calculation for you to show what they did. Well, you have to spot first of all that the line of symmetry is 1.75. Clearly between 1.5 and 2, these appear to be the bottom points, but between this and this point here we have 1.75. Therefore, if you use that and substitute it into the equation here, I'm going to do it for you now just to test it out. So y equals 2 lots of 1.75 squared, take away 7 lots of 1.75 and then add 5. Let's just do the bits and pieces. that means 2 lots of, we'll just do 1.75 squared. That is not nice. That is 3.0625. Take away, I'm going to do 7 lots of 1.75 now. 1.75 times 7. So it'd be minus 12.25, and then I'm going to add 5. So what I'm going to do now is multiply this by 2, take away that, then add that. So here we go. 3.0625 times 2, press equals. Now I'm going to take away 12.25. I want to press equals. Then I want to add 5. And I have in fact got minus 1.125. Now really, on a graph like this, drawn freehand on the screen, even on paper, you can't read off honestly minus 1.125. I read it as minus 1.1, and that's pretty good, where 1 square is worth 0.1. You can't read it any finer than that on graph paper like this, so I'm very happy with that. So the question, find the coordinates of the minimum point. It's this, 1.75, the x value, comma, minus 1.125 on the y. So it's a very ugly looking coordinate, but it's completely correct, and you had to read off the equation of the line of symmetry and then suss out and realize that in fact the x coordinate for the minimum point is 1.75. Substitute it back in and calculate it. Didn't say calculate though, they should have done that. I just read it off the graph, and I'm happy with that. I'm going to stop.